In this example, we're asked to use the definition of an ellipse, PF1 plus PF2 is equal to twice A, directly to find the equation of an ellipse with foci at 0, 0 and 4, 0, and major axis twice the A is equal to 6. So I drew a diagram for you so you can understand what we're talking about. So PF1 is actually the distance between an arbitrary point on the ellipse, which is going to be here. This is an example point. There can be infinitely many points, of course, on this ellipse. This is an example point with coordinates x, y. So we're talking about the distance between this point and the first focus, plus the distance between this point and the second focus, is equal to twice the value of A. And A is going to be the distance between the center and the major vertex. Okay, so this distance twice this distance, and notice that twice this distance is the full diameter, or you can say the major diameter that constitutes the major axis of this ellipse. So this distance from one major vertex to another is going to be the sum of these two distances. And notice that we're talking about any point. Any point will hold this equation true. Okay? So for example, this point can be on the major vertex itself. So imagine that this point is instead here. This equation still holds true. So in other words, the distance between this major vertex and this focus, plus the distance between this major vertex and this focus, is going to be the twice A, or the full distance between the major vertices. And as you can see, it mathematically makes sense if you view it this way, right? Because this distance plus this distance is the same as this distance plus this distance, right? Because these two distances are the same. The major vertex distance to the second focus is the same as the major vertex, the second major vertex to the first focus, right? So if you visualize it in such a way that you're talking about the full diameter, which is equal to the twice the A, then you know for sure that you understand how this works, okay? So in this case, we're trying to use this definition, and we're trying to derive the equation of an ellipse by using this. So we have to convert this by using the distance formulas for each of these distances described on the left side. So the PF1, what is the distance between the point and the first focus? Notice that the point is arbitrary. That's why there's coordinates x, y, right? We don't know what the coordinates are. It's arbitrary. It can be any point on the ellipse. That's why it's variables, right? So we know by using the distance formula, the distance from this point to the first focus is going to be x minus let's name this focus 0, 0. Okay, this focus has coordinates 0, 0. Right, so we have to subtract 0 using this distance formula, the x coordinate of this focus, and then y coordinate of this point minus the 0 coordinate for the y coordinate of this focus. Okay, and that plus now the distance for from this point to this second focus is going to be what? It's going to be x again minus, now this time the x coordinate of the second focus is 4, right? So we have to put 4 here, squared plus y, right? The y coordinate of this point minus the y coordinate of the second focus, which is 0, squared is equal to twice the A, right? Twice the A, and that's given as 6, right? So we're just putting 6 here. So now we can actually simplify this. We know that this first term is going to be x squared plus y squared, right? Because subtracting 0 does not affect it, and x is being squared and y is being squared, right? And then plus, and here we're going to have x squared plus y squared minus 8x plus 16. Okay, and I got this x squared minus 8x plus 16 I got from this binomial being squared, and of course I'm adding the y squared, which you see here, and that's equal to 6. Now what I want to do, I want to subtract 6 on both sides. We got to get rid of these square roots, right, somehow. So I'm going to subtract 6 on both sides, and I'm going to subtract square root of x squared plus y squared minus 8x plus 16. And the reason why I want to bring this radical on the right side, so that we can square both radicals effectively. It will be much easier than if we try to square it as it is right now, because squaring two radicals on the same side, these are separate radicals, will be really problematic. You will not be able to solve it that way, right? So I have to subtract the second square root on the right side as well. So this is what I'm going to have. So as a result, this is what we're going to have. We're going to have x squared plus y squared minus 6 is equal to this radical, right? So it's going to be minus, and minus will not change anything, right? Because when you square the minus, when you get rid of the square root, squaring the minus gives you a plus, right? So it doesn't matter if we have a minus or not. Don't be thrown off by this minus existing there. So x squared plus y squared minus 8x plus 16. Okay, so now we're ready to square both sides. If you square both sides, keep in mind that you have to treat it as two terms. You have to treat this part as two terms, right? Because this part, if you want to square it, this part has two terms, so that means you're going to use a FOIL method, right? So the first product, the f product, the first product, is going to get rid of the square root, right? Because square root of x squared plus y squared plus itself times the square root of x squared plus y squared gets rid of the square root sign, right? So we know that the first product will be just plain x squared plus y squared. That's good. Now the next product, the O, the outer, will be negative 6 times this. And then the inner will also be minus 6 times this, right? So it's going to be twice that product. Twice minus 6 times this is minus 12, right? Because 2 times negative 6 is negative 12. Square root of x squared plus y squared. And the last product is this times itself, negative 6 squared, right? Which is plus 36. And of course, squaring that is easy, right? Just get rid of the square root and get rid of the negative. So it's just x squared plus y squared minus 8x plus 16. Good. Okay, so now notice what we need to do now. We need to actually get rid of this square root. We have to move the square root on the right side. Okay? We have to move the square root on the right side, and also we have to get rid of these, right? So these are gone, notice, because they're the same terms. And what we have as a result is going to be we're going to move the 36 on the right side as well. Let's move the 36 on the right side. Let's subtract that. And let's actually keep this square root here. So if we keep it here, what we're going to have as a result is, let's just write it down. Negative 12 square root x squared plus y squared is equal to minus 8x minus 20. All right, so this is what we have, because these two are like terms. So now we can square both sides, and we will effectively get rid of the square root, right? So squaring both sides, I know it might seem like we're working backwards, but we're not, right? Because we squared something else before. We squared two square roots, and now we're only squaring one, right? So we're getting rid of ultimately the last square root that we don't need, right? Because we know that our equation of an ellipse will not have square roots in it, right? We know that definitely will be true. So squaring this gives us 144 because each part gets squared, right? So negative 12 squared is 144. Now the square root is gone when you square this thing itself, so it's going to be x squared plus y squared is equal to, now squaring this will give us what? Will give us 64x squared plus 320x, right, using the outer and inner products, and then plus 400. Okay, so that's what we get. So as a result, you subtract 64x squared because you know that there will be x squared there. So subtract 64x squared. Subtract 320x as well. Right, let's see what we have. Minus 64x squared minus 320x. Let's see what we get there. So as a result, we have 144x squared minus 64 is going to be 80, I believe. 80x squared, right? So 80x squared. And then 144y squared, we don't have any y squared there, so we can just keep it 144y squared, and we keep the sign, minus 320x, okay, is equal to 400. Minus 320x is equal to 400. Minus 320x is equal to 400. And now actually let's divide, because these terms can be reducible, right? So if we divide by 2, that's possible. If we can also divide by 4, all of these. 144 can be divisible by 4, I believe. Right. 320 can be divisible by 4. So let's see. What about by 8? By 8. Right, and by 16, right, by 32, I'm not sure, maybe by 32, no, by 32 is not, so we can divide everything by 16, and that will actually reduce all of these numbers that we don't need. So as a result, let's keep working there. Let's keep working in this section. So 80 divided by 16 is 5, right? So 5x squared. Let's write the x to the first power next. Negative 320 divided by 16 is going to be minus 20. 144 divided by 16 is 9, right? So 9y squared is equal to 400 divided by 16. I believe that's 25. Okay, so that's 25. So now we need to complete, well, before you complete the square here, you need to actually take the 5 out. So x squared minus 4x, right? I'm just factoring these two guys. Correct that a little bit. 4x, right, plus 9y squared is equal to 25. Okay, so now I can complete the square, right, for these two terms, because we know that when it comes to ellipse, we need to complete the square. Since you have two terms in x to the first power, this calls for completing the square, right, so that we can get it in standard form. So x squared minus 4x, now plus taking 1/2 of this and squaring it, right, that's completing the square. That's going to be minus 2 squared, so that's 4. And close the parentheses. And now minus 4, because it wasn't existing before, but minus 4 multiplies the 5, right? So minus 20 as a result. Plus 9y squared is equal to 25. So now we have 5 times x minus 2 squared. You see, this is a perfect square trinomial, which is why we needed to complete the square to get it. perfect square trinomial becomes a binomial being squared, right? If you use the FOIL, you will get this, right? It's basically x minus, basically writing 1/2 of this after the x. 1/2 of this coefficient is minus 2, x minus 2, right? Adding 1/2 of this coefficient, basically, to the x, which is x minus 2 squared. And then this is minus 20. Well, let's write 9y squared first, and then let's add the 20 while we're at it. Add the 20 on both sides, because that's a constant. And we will get what? We will get 45, right? 45. So now, you know you have to divide both sides by 45, because we know that in the standard form equation of the ellipse, we have to have 1 on the right side, right? So we have to divide everything by 45. So as a result, look what happens. 5 gets canceled out with the 45, right? Reduces. 45 divided by 5 is 9, so we get 9 here. Here 9 gets canceled out. 45 divided by 9 is 5, right? So that's good. And the right side turns into a 1. So we get x minus 2 squared divided by 9 plus y squared divided by 5 is equal to 1. So you've successfully derived the equation of the ellipse. As you can see, this was a long process by using algebra, but you actually use the definition of an ellipse directly to find and derive its equation based on your knowledge of what it means. So I hope this was useful. Thanks for watching. See you in the next video.